teach the following topics, means IP addressing schemes, and then I will also a little bit give introduction to DHCP and ICMP, which was done during the lab. Okay, so let us plan to complete it by 11. So we have around 40 minutes. So let us first look at the two things that you need to learn about IP layer, which is again L3, and then we have L2, which is data link layer, and then physical layer L1. Now we are going to concentrate on the L3 layer. Primary job of this is to route the IP packets from the host to the destination. Okay, from source to destination. The purpose is to take the IP packet. Now inside the IP packet you have a data which can come from L4, whatever video or audio or files, whatever data that IP has is carrying. Now just to summarize, this IP layer IP packets cannot travel, they need to be carried, though they have a source IP address and destination IP address and other fields that you have learnt about IP header. We need to have a carrier which is nothing but Ethernet in our case, which is taking us carrying the IP packet inside as a payload, takes it to the intermediate routers, which will receive it on one side, open up the IP packet, looks at the source and IP addresses, source address and destination IP address. Basically, it is looking at the destination IP, where to pass it across. Now, before they do it, they look at the destination IP, the routers, and then check, am I on the same network? Okay. As you are aware, a router has multiple interfaces it is connected to. So those interfaces are on some network. Let me call this as a network, and it is on one side it is coming in, and then router is sitting on multiple uh, networks, and it has an IP address which is having a destination IP, and then it is trying to see whether, one second. Yeah, what? Okay, okay. They individually they ask them to connect. Okay, I cannot. Please don't disturb. Okay. எல்லாரையும் உள்ள போக சொல்லு, எல்லாரையும் உள்ள வர சொல்லு, and then start. Okay. They should not disturb other classes. You say that I will note down the names which are who are outside. Then we will not give attendance. Okay. Yeah. Okay. Hello. O- Okay. So let us continue. So what is? Let me go to the next slide. So what does a router do? We'll try to understand quickly and then move forward. I cannot do this with this. Okay. So initially, first, what does routers do? They will check the destination IP of the received packet is same as the network on which the routers are. Okay, individual router is. Now, how does it check it? It knows the network ID of the net ID portion of the input packet, and then it also has the subnet mask. Okay, it has subnet mask as well as the network IP network ID of each network they are in. So they will compare the based on the type of class A or class B, what type of the packet which is coming in, because you remember that IP packets, when they are passed, they do not have the subnet mask passed along with it. So it will go by the prefix matching maximum whatever it can match with the input IP address. So whatever IP addresses are there on the network in which they are there, it will compare against that which is coming in. If it has a maximum overlap, or if it exactly matches with the network what it is on, it will not further try to route it. It will try to find the host on the network which is targeted for. Now, if that decision doesn't pass, that means the input IP address what you are received, destination IP address, is not matching with any of the network it is on. That means this packet is further needs to travel across. So it has to now look at the routing table. Okay, then only it will look at the routing table inside the router which is configured, and then tries to do the same thing. Of multiple entries are there, then it will try to do the maximum what is matching with the IP addresses given in the routing table. Now it will pick up one entry, and then it will find out the interface to which is supposed to be sent. So now imagine that it has to further travel, then you cannot send that particular IP packet on this network, because if it finds that interface 2 is the place where it is supposed to go, no host on this network can receive it. It has to be another counter router who is a counterpart of this router can understand the routing information. So it has to be sent to another router. So how does it know? It knows the routers which are there in each network also based on the routing protocols running on them. So it will know, okay, there is a router here R2, I am R1. I need to send it to this router because I am supposed to route it on this interface. So what is it doing? It is going to ask for the if it doesn't have the MAC address of that router, it will ask for the MAC address, and using the ARC protocol, then it will send it to that router. So that's all, job is done. Looking at the routing table, it will take a decision. So just to summarize, IP packet comes in on Ethernet, it receives the Ethernet frame, opens up the IP frame on it, and then it will look at the destination IP address and matches with the interfaces or the network which is it is on. If it is not on one of those networks, it is supposed to go further down to some other router. Then it will look into the routing table entry for the given IP address, destination IP address. Do I have an entry which is matching with one of these entries in this? And then it will find out the interface on which they are supposed to go. Then it will send it across. Then it will send it to the router on the that particular net interface. Okay, interface is sitting on some network as I told you. So on that network, apart from host, there will be one more router, which there can be many also. It's not that only one. Maybe it will find out whatever is interface it is on that router, particular router. It will try to look for the ARP address of MAC address of that particular one, and then send the packet further. That means what? It will put the same IP packet inside the another Ethernet frame and send it across. Okay, that's what it is done by the router. Now, one more thing, when you are looking at the routing table, okay, routing table, there are IP addresses and matching interfaces given. Okay, that's what we configure it in the Cisco packet tracer using via command. Now, what if I don't have any of those IP addresses matching with my destination IP? Then it is a problem that every router need not have to know the places where it is located in the huge network internet, and it will not have an entry for all the IP addresses that it sees on the packets. So what does it do? It has to now take a decision by sending it to a default route. There will be a default route set on all the routers, which is defined by 0.0.0.0, that is the IP address, and subnet mask is 0.0.0. That means any IP address, if you don't see, it is the order in which they are checking the routing table is important. It is not going to come here. That means every IP address will be matching with this and it will send it all of them in the default route. That is not going to happen. You are going to check all the specific IP addresses given, and that also it will say maximum prefix match. Okay, it will, the prefix is the network ID portion, and maximum which is matching, that is the place it will take, that is the interface it will take and try to send it across. It will try to maximize the correct routing, but if it doesn't find one, then there is an alternate path which is a default route. Like in switch statement in C, we have case statement, case 1 2 3 whatever, and then you have a default. So it is not going to directly jump to default, then none of these options will be selected. So routing table is going to check the matching IP addresses initially, and then if it doesn't find one, then it is going to find the default route, and whatever interface it says, then find a router on the other end and send it to that particular router. So that's why IP routing is called best effort. So it's not guaranteeing that every packet that you send on the IP network will be delivered in a given time or within a particular hops. So that's what I mean by hop. I mentioned a new word now. Hop means how many routers it is supposed to jump across before reaching the destination. Now, there may be a possibility that the IP packet may go around because all the routers which are on the way, they do not know the proper routing tables are not updated, and you have introduced some new IP address. Then what will happen? The IP packet will go around the internet, which can be avoided by TTL, time to live field in the header, which is decremented by every router. And whenever it sees that the TTL count becomes 0, that IP packet is discarded and it's not going to be forwarded anymore. So that is how a routing happens. Now let us look into IP addresses. Now how does IP addresses help us in achieving this routing of packets? So there are two addresses that you come across: MAC address and IP address. So let us see why not MAC address and why we decided to use IP address for routing. Now MAC addresses are, as you are aware, it's for physical links between two devices. It could be any host or it could be a router. They have a MAC address associated with them. Okay, every interface that you have on a router has a unique MAC address. Similarly, every host connected to the network also has a unique MAC address. Now you may wonder, what if I have a LAN where switches are there, hubs are there, and also bridges are there. They are all like a connections. It's like a connecting to wires. Okay, whereas macs are like sockets. Okay, like what where you can draw power from. So you don't give an address for every connection that is made in a switch. So switch interfaces, or we don't call it as interfaces, we call them as port. So always the different naming conventions are used to different, at different layers. You say frames for ethernet and ports for switches and hubs and bridges. And when we come into L3 layer, we say packets, IP packets, and we call the router interfaces. Okay, we don't call router ports, we call it a router interfaces. Then you know that interfaces only have a unique MAC address, and that is what you can address to send the Ethernet frame to. So you cannot send a Ethernet frame specific to a particular port in a switch. A port is actually a passage for Ethernet frames to pass across. That's all. Okay. Now let us look at why not we use MAC address for routing, because MAC addresses are not hierarchical. When I say hierarchical means you should be able to, based on the address, you should be able to find out where exactly in the network it is likely to be. Like not exactly, maybe more or less. Now how do you know it is a physical location based? IP addresses are allotted by ICANN, which is a organization, international organization allocating IP addresses for different countries. Then each country, and not even countries, even regions, Europe region, North American region, and Asia Pacific, and each region they distribute again the IP addresses to different countries, and different countries give it to different service providers, and the service providers give it to the individual users. So as you are aware, this actually enables us to have high, geographical um, alignment of different IP addresses where they are likely to be found. Now you have all over the world routers and then undersea cables, and those routers are configured with already some routing tables based on some routing protocols, which is across the uh, internet. It's not specific to a particular small network or something. So based on that, the routing tables are updated, and IP addresses are used for routing, because this you can actually localize them based on the physical geographical areas. Now why not MAC address? MAC addresses are specific to a company and who is manufacturing those interfaces or network interface card, or you may have a LAN port or a Wi-Fi. Phi, we normally call it as a Phi. Physical interface to Wi-Fi is called a Phi. Phi is a device which is manufactured by companies, semiconductor companies like Broadcom, Qualcomm, and then they embed their MAC addresses in them. So a laptop or a mobile what you buy has a MAC address embedded into them, and you may buy it from any country and you may use it from any other country. So you cannot route based on the MAC addresses because it doesn't have any geographical location or anything associated with that, or they do not have anything specific according to the structure in which it is planned. MAC addresses are designed, they do not have any hierarchical structure. Now IP address has network ID portion and host ID portion, and even network ID and the host ID also can be subdivided into subnet ID, which we will cover soon. So those kind of hierarchical organization of IP addresses helps in routing the packets, whereas that is not there in MAC address, because MAC address has a company ID which is manufacturing the uh, interface, and then it has the individual sequence, a serial number specific to a particular device manufactured by them. So MAC address is not suitable for routing. Now let us come. We have decided that okay, we cannot use MAC address. Now we have to use IPI. Now IP addresses, how are they organized? There are basically five types of classful addressing. A class A has the first bit of, this is bit 31. As you are aware, I am going to talk about only IPv4, okay, which is 32-bit IP address. Always the lower, MS bit of this address, if it starts with a 0 and the rest of it is treated as, if it is 0, you can assume that it is a class A address, okay, there is no doubt about it. And then there are 8 bits of host network ID portion and 24 bit of host ID portion. So what does that mean? You can have 2 to the power 24 minus 2, because I am avoiding all zeros and all ones because they are used for broadcast purposes. You cannot use it for a specific host on a network. So this many hosts can be there. These many hosts can be there. Now what about the network ID? It can be only 2 power 7, right? Unique combinations of 2 power 7, because one bit is gone for identifying that it is a class A address. Now what is the significance of class A address? This address can have less number of network IDs. You know, a network belonging to the class A addresses are less, whereas hosts are can be more. So if you want to build a huge network, when I say huge means the number of um, sorry number of hosts in a particular type of network is more. Okay, you can add, actually, you can have 2 to the power 24 minus 2 hosts in the network. So this is for meant for a bigger organizations. Now come to another address, which is class B, which is starting with 1 0. That means I am making this as a 1 and then the following bit also 0. Okay, this means that it is a class B address, and 16 bit top, this is MSB again, M31 and B30 B0, this is 16 bit. This is a class B address where you have 2 to the power 14 unique locations are there where you can have class B addresses. So and you can have 2 to the power 16 minus 2 hosts in it. So this is a medium type of network wherein you can have medium sized organizations can look for this IP address. They can choose them. Now if you have another one is there, class C type, which is 3 bits are taken away because you need to differentiate the bit positions so that it is unambiguous when you are trying to look for a particular type of a address. So 3 bits are gone and you have divided this as a 24 bit for network, and remaining 8 bits are only for host. So this will be 2 to the power 8 minus 2, where less number of hosts are there, 254 hosts, and then you have many networks of this type can be constructed. So these are the addresses which are given for anyone asking for IP address, and based on the need, based on the type of your whole company, you can choose whatever type suits you, and you need to use it for your purposes. That is for public IP address, which is universally known across internet. Now there are two more which are also there in the classful addressing scheme of IP, wherein you have first 4 bits are given as to differentiate what type of this IP address is. This is class D, and this is meant for multicast. So let me just briefly talk about multicast. You may wonder that why not there is some network ID portion and the host ID portion in the multicast area. Remember, multicast, as the name suggests, it is not a unicast where you are trying to send a message to a particular host in the network. All other class A, class B, class C addresses are meant for unicast purpose. You are sending it to a particular host and they are going to have particular IP address. That's why the addresses of class A, B, C are divided into network portion and the host portion, whereas multicast addresses are not divided as network ID and host portion because it is not meant for one particular host. It is for a set of hosts. So how does the multicast addresses are managed? That's also given to a particular organization who are into broadcasting of information, streaming of things like HBO or Star Sports or what are the no media houses where they want to stream data to many people, then they are allotted for their own purposes a multicast address. Now you can wonder that 4 bits are gone out of 32, so remaining 28 bits are there which can be used for a multicast addresses. So it is given across the world for the people to use it. Now how does the multicast work? When you are sending, suppose you are streaming a cricket match and all the different countries are watching it, from the different countries different users are watching it. Now you have to actually sign up for a particular stream. Okay, different people will be signing up for the particular stream happening, and the person broadcast 1 second, something happened. Okay, so particular company who is streaming it, they will be having no particular chosen a particular multicast address, and then they will stream it. Now what happens, suppose in a region you multiple users are watching a cricket match, they will be sending the streams of video data. Maybe one packet will come to the particular area and then it will be broadcast. That means it will be multiple copies are made and individual host will be delivered. So they will all be registering for that particular multicast address and they all get the stream that they come in. So there will be some optimizations done in streaming the data because all of them are watching the same live telecast. So that will be reused data will be there. But if you are signing up for a particular movie, if you are watching which is not a live telecast, then you don't need to use a multicast. You can use a TCP connection, which is connection oriented socket connection from the host to the media server, and you get the data streamed to you directly. Okay, that will be using a specific IP address, one of the IP addresses that you have seen across. So this is how the IP class D address is used in the multicast scenario. And there is one more called class E, which is reserved for future use, wherein all first 4 bits are ones. Okay, so I hope this is clear to you based on the different types of classes. And now let us look at two things which I wanted to cover, DHCP and ICMP. Now let us look at the DHCP. Though you have all done the labs using this, let us understand what we do normally in configuring it in the lab. Okay, let me tell you that we have a router. Okay, let us have a router because the scenario will be better understood, and I will have a switch. Then we have a server. I will call it as a DHCP server. This is a switch, and we have host. Now host, I'll say host 1 and host 2. Now first of all, this router whatever is there need to have be in this network. And one thing you remember, when we are using a DHCP server, what is the purpose? Let me start with that first. Now what is DHCP? Dynamic Host Configuration Protocol, wherein we don't need to go into the individual IP. Where is the picture gone? Oh, something is happening. Sorry, I lost the picture that I have drawn. Okay. Okay, so you don't have to configure each of those IP addresses on each machine. what you do is you don't want to do it individually, because if there are, as I mentioned, to class B, class C, class D, A addresses are there where you can have 2 to the power 23 or 24 kind of host in it. It's not physically possible for you to go and configure the IP addresses which are not clashing with each other. Okay, because IP addresses in a network cannot, any network need to be unique. So we take the help of this protocol and we configure one particular server. Server means any machine which is powerful enough to run the DHCP protocol, and it is on the network. So what you do, you need to statically allocate the IP addresses for IP address of the DHCP server first, because it is going to provide the IP address for everybody. It should know what is my own IP address, because especially in the packet tracer, Cisco packet tracer, you need to configure this first. And then also this interface of the router, it can be in any order, but I would prefer maybe you do this first and then you do this second. The reason being, the DHCP server comes to know about where it actually connected to, which network it is connected to, looking at the interface, the fast Ethernet interface of the server, what the IP address it is configured as. So based on that, it learns that I am sitting on this network, so I am supposed to provide IP addresses belonging to this particular IP address. That's why the pool of IP addresses it chooses is actually decided based on the interface IP address that you configure. So whenever you are configuring these IP addresses, you will also be providing the subnet mask. Now, you may wonder that there is a router does not have a default gateway. Okay, it has a default route interface. Okay, it doesn't have a default gateway. The reason is it is not going to generate any data packet. Okay, router is not sitting there to generate data packet. It might generate some routing protocol information, like bridges generate spanning tree protocol packets. Routers may generate some routing information protocol to align different routes on different routers, but it is not going to generate something which is it wants to communicate with some other host on the network, not normally. But if you are actually mixing up a host and a router, because their host itself can play as a router also, then means it is possible. I am just saying that given a scenario wherein router is having a specific job of only routing, then its job is to receive a packet from some network and pass it on to somebody else. Okay, so that's how it is configured as. So what you do, you don't set a default gateway in the router, you don't find an interface for that, GUI interface. Whereas in the servers, the DHCP or host, you have a default gateway. Now, what you do is in DHCP server, you configure default gateway also, because for that you need to have configured the routing interfaces IP address. And then what you do in the DHCP server, you configure the IP address of the interface, you configure the default gateway. Okay, and then you have to start off a DHCP service. Now, DHCP service is which is going to be running, looking for any host on that network, asking for a IP to be allotted. So what does it do? Before configuring, you have to say that what is the pool of addresses you want it to distribute. Based on the size of your network, based on the number of hosts that are going to be there in your network, you can decide about the number of IP addresses that you are allocating it. So it will make sure that it is not giving the IP address of the router which is already taken, and of course it will not allocate the IP address of its own interface to somebody else, because in a LAN or anywhere in the net the IP address has to be unique. So it will take care of that by be conscious about it, and then the rest of the IP addresses are going to be given in some order. Now once you do this, okay, what happens is the hosts are going to get all the IP addresses. Now let us see what is the interaction between the let me talk this as a client. Okay, because it's similar to client server protocol, wherein the DHCP is called as a client server, and all the hosts which are asking for IP address are called client, and any interaction between one client and a server, and a server meant for servicing multiple clients requests, is called client server organization or architecture, client server architecture. Now what happens when this particular thing um, is happening? Now what happens is, it is saying discover, it is going to send a message, discover message on the LAN. So let me give a scenario where you have a LAN, and you have hosts are connected, different hosts are there, this is a LAN supposed to be, and we have a server. Now, when the LANs come up, or sorry, when the hosts come up, they are connected to switch or through some interface. They are in the LAN. Okay. Now, when the hosts come up, they don't know whether they are configured as uh, uh, statically allotted IP address or dynamically getting it from DHCP. That you need to inform the host. That's why sometimes when you are configuring it, you need to go to the individual laptops or a host, and then there are two options there: static, and then DHCP is there, IP address. So you choose this. Suppose already it is chosen, you come to DHCP and then come back. You choose, okay. Or already DHCP is running and then it has given a wrong IP address of 00 or 164, some 129, some other number which is a standard number which is given. Then what you do is, if it is not choosing one of your IP addresses, come back to static and then go to DHCP again to initiate the DHCP interaction. Then what happens is, whatever you are configured in the DHCP server will be contacted. Okay, the individual hosts are going to do this. The diagram what I am showing is a ladder diagram. Normally we show the protocol exchange of information in a ladder diagram, wherein the first message which is initiated is shown here, and then it is saying that, okay, I am response is given, wherein it says that yes, I am there to offer, IP addresses to you. Then it will request, I actually need it, then it is going to give you acknowledgement as well as the IP address. Now what all does it give? It gives you the DHCP server gives you IP address, unique IP address which is not allotted to any other host, and then it also informs what is the default gateway that you are currently on. Okay, because it knows that you are already configured in the DHCP server, and it also knows that the router interface is matching with the default gateway, so it will send that default gateway information also to the host. Why are we setting it up? Because a host needs to communicate. It doesn't have anybody else other than the default gateway, which is supposed to be the router's interface on the network, to take help from. So when the host comes up, either you have to statically go and allocate this, configure these IP addresses, default gateway IP address and its own IP address, or you do take the help of DHCP server to do it. Okay, so remember that normally the ladder diagram is shown. The messages are exchanged in little slanting. The reason being, this is the time scale. Okay, top to bottom is a time scale which is going in the time order, and when a particular host is sending it, it is going to get some uh, time for the message to reach the other side of the thing. It could be between two hosts, or it could be between one host and a server, or whatever it is. It is going to take some time for the delivery of the packet. That's why there is a slanting line for the ladder to be. Ladder diagram shows you how the messages are exchanged. So this is how any protocol can be understood. Okay. Now let us look at ICMP. What is ICMP before we wind up in another 5 minutes? Um, it is an internet control messaging protocol, wherein you use it for seeing the health of the uh, machines or the host, or even whatever message, even the links. Okay, if a particular link is up or down, you can actually verify it by using some of the commands provided by the ICMP. Now this ping and trace route, which you might have already heard of, they're all applications, which is, that's why you are able to use it on the command line prompt, because anything that you do on the command line either has to be one of your executable, or it is a built-in commands of the OS, or some of the services provided by the different applications running on them. If you have installed some tools or something on the thing, then there will be executable which is, whose name is there in the path variable of a particular OS. Path variable is an environment variable which gives you the different paths of binary files. When you give any command, what does the OS do? On the command prompt, whatever you type, it first of all, if it is an internal command, internal OS command, like a directory or ls, it knows and immediately it acts on it. It runs a program to take care of the ls command. Or if it is not falling under one of them, then it will go into the path variable and then searches all the different directories given in the path. It could be separated by semicolon or a comma, based on the OS you are running, and it goes and looks for the particular executable you are given on the command prompt, and if it finds one, it executes it. So ping and trace routes are applications which are part of the networking application which is running on the network, running on the host, which helps you to find the path. Now, let us understand what happens when you do ping. Suppose I am saying that ping 10.0.0.2. Now, it has to be sent, and a host, it is being generated from the host. So what does it do? It has a gateway, default gateway, which is set to this IP address of the router, and it will find the ARP address of the router and generate a IP packet, and it is generated from ping. So ping is coming from the application layer, and then UDP is UDP packet, which is L4, is where the ping information is put inside the UDP packet, and then IP packet is generated, uh, giving the destination IP address this and the source IP address of this machine as source IP address, and then given to the Ethernet frame after finding the default gateway. See, remember this ping command, first of all, if it is in the same network, then it doesn't have to go to the router, right? So the host first checks whether am I on the same network. 10 means it is a network ID is this much and host ID is this much. So it will check whether am I on the same network. Then it will not send it to the default gateway. It will directly get the IP address of the another host on the same network, and then it will send it to that host. If it is not, then it will send it to the default gateway. So the destination IP address will not change. Only the MAC address of MAC address of the Ethernet frame will be pointing at the router's interface. Please don't think that I am going to rewrite the destination IP as the default gateway IP. Then I am losing what I am really interested in pinging and getting the information about the life of that particular host, whether it is live or not, whether it is willing to respond to me or not. So that's how things happen. And whenever the ping packets are going across the routers, what does the routers do? They decrement, as usual, they do a decrementing of TTL. But what happens with the ping command is, because it knows that ping command is a part of ICMP protocol, which is at the L3 layer. So if it is a ping packet and a router finds that the TTL value has become 0, then it is supposed to respond back to the owner or a source IP address saying that I am dropping it because I am not able to reach the source that you are looking for. Yeah. Okay. So this is how the ping command works, and the trace route is a extension of using the ping. If you want to know the path a particular destination host is being reached through what path, what you do is TTL value is initially made as 1, and the first router will decrement to 0 and send the response back. And then the host will know that okay, I am going through this router. It will send the interface which is contacted to reach this router. Then it will increment the TTL2 and then send it again to the same destination IP address. Now the packet traverses one more router and gets dropped here. Then this router will respond back. So similar to that, until it reaches the destination, TTL value is incremented, and every time the packet is sent. You can imagine the amount of traffic it is going to generate, because every time it comes back, and then it goes up to this and comes back. So it is here what we are assuming is that most likely the packet is going to go through the same path, or even if it is taking a different path, you will not even know. In the middle something has happened, you will TTL value when becomes 0, you will get back the response. So this is how you find out until it reaches the destination. You will know what is the path it is taken. Okay, so I think this actually covers two sections of 7b and 7c. More or less I tried to cover what was there. Maybe one or two might have got missed out, and I am sure the slides will help you. And I urge you, if you have any doubts on any of those topics, please message me anytime. Not one day before the exam, but because I get hundreds of messages. But even before that, or after, or during when you are studying, you can always ping me on that. So if you have any doubts, maybe we'll give 2 minutes for some interaction in case possible. Otherwise, we can drop off. Okay, I am not sure whether classes are listening or not, but at least this recording will be available for you to watch it later. Okay, bye bye. See you next week.